All right, let's see. So um,
Oh,
today I was going to cover compile time computation. Um, let's see. Zoom. There we go. Today I was going to cover compile time computation, but this is a Python class, and compile time is only really relevant for heavily compiled languages. And so it's not really very relevant for Python. The only way to go over it would be to switch into Java and C++, which is gross. Um, so I might do that eventually, maybe if there's time at the end of this lecture, but most likely next lecture. But I thought it would be more fun to finish up what we were doing last time and then take that to even more extreme examples. And we're going to end with demonstrating some code that I wrote yesterday that uses attributes and descriptors, all that good stuff. So yeah, let's see. Let me share my screen. All right, there we go. Does everybody see the slides? Cool. Also, before I get into it, I want to try taking attendance with the chat. So if everyone could just chat their computing ID real quick, that would be awesome. Oh man, I'm blowing up. All right, awesome. Yeah, sweet, cool. All right, so last time we were doing attributes and how they get looked up on instances versus classes. So, we saw that there was kind of a hierarchy of attribute lookup. If you have an instance of some class, like a specific object, and you access an attribute on that object, first we check the dictionary for just the object. And if we don't find it, then we fall back to the classes dictionary. And then we look all the way up the inheritance tree for a definition of that attribute that we're trying to look up. And we even had some hooks to be able to get into that process. Like we could define the getAttr method, and that would define how things get looked up on instances of that class. And that ended up being pretty useful. We were able to write a class that was immutable by overriding setAttr, which overrides how you're able to set attributes of that class. But then we kind of briefly got into method binding, because it turned out that method binding was kind of weird. Like we have the instance dictionary, which does not have an entry for the method, and then we have the class, which does have an entry for the method, but it's a function. It doesn't have a reference to self. But then somehow by referencing the attribute on the instance, even though the instance doesn't have the attribute, it somehow gets bound, and somehow this now has a reference to self, and it gets passed in, even though we didn't do that manually. And we saw that that has to do with the dunder get method. And the dunder get method defines how instances of that object get looked up on other classes. So here, if a bind me object is the value of some class dictionary, it's the value in some class dictionary, then looking up that value on instances of that class will call this method. And so bind me objects override how they get looked up. So if we say t.x, we're doing a lookup, we're doing a get attribute on this instance t. We don't find x in the instance dictionary because it's empty. This is a brand new object. But we do find it in the classes dictionary. But finding a bind me object in the classes dictionary calls this. So we get that we're binding this object, this bind object, to the instance t test object. And then we also get the type, which is kind of extra information. And then the value that we actually got by looking up x on t was hello descriptors. And that's because the get method returned hello descriptors. So we're able to both hook into the process of looking up the attribute and change what gets looked up. And then if we look up x on the class itself, we also get this method called, but instead of binding to t, the instance of test, we bind to none. So looking up an instance of this descriptor on this class itself tries to bind it to none. So we can tell if we're doing a static lookup if object is none, and we can tell if we're doing a non-static lookup if object is some object. So this isn't a very useful example, but it's just so that we can see when dunder get gets called. Other questions about this? I feel like we went over it pretty quickly last time, so I just want to get back into it. Dunder get method? Any questions?
Oh, wait, yeah. Like, why is the dunder get method, like, if you had like some other like caller like in the class find me, like, would that be called instead?
Some other caller in the class bind me? What do you mean by that?
Like usually when you like call like your class, like if you define like another like callable method, like that would get called. I'm confused on why like get is being called, or dunder get is being called.
Well, so so I guess, are you talking about if we had implemented like a get attribute in bind me, or if we had implemented get attr in test? Because both of those could kind of change the interpretation of what's going on.
In bind me.
In bind me. So get attr defines how you look up things on the class that you are. So if we had defined get attr or set attr or get attribute, any one of those in bind me, then if we had said x dot something, then that would have been called.
Okay.
Because we're looking up on the instance of bind me.
Gotcha.
What get does, and it's really confusing because of how it works, get doesn't define how you look up things on instances of that class. It looks up how instances of the class are looked up on other things. So we're looking up this instance of bind me on T, but get is going to override how that lookup ultimately gets done.
Okay.
So yeah, it's kind of a reversal of how we usually think of defining attribute lookup. Does that help clarify?
Yes.
Okay. Other questions about get? All right, I'll move on. And if there are questions, just let me know, because we're going to continue doing get, because it's cool. Let's see, we did some static method stuff. A static method is just a method that doesn't take in self, basically. So we can call it on instances, we can call it on C, or we can call it on the class itself. Both of those work because static method makes it so that self doesn't get passed in. And then I think we did this briefly last time, but I kind of rushed through it. This is just a decorator, right? It's just a static method. So it could be kind of fun to try writing it. And we tried writing it in just kind of a naive decorator way, where we define our decorator, which takes in a function. That's the method that we're trying to make static. And we're going to assume that that function by itself does not take in self. And then we're going to define a wrapper function that does take in self and throws it away for us. So effectively, we can write functions that don't take in self, but they'll still work. So that's the idea here. So like, if we decorate this foo function, it doesn't take in self originally, but then after being decorated, it does take in self, it just doesn't use it. So that's the intuition here. And this works for instances. So if we call c.foo, c is going to be passed in as self, and then it's going to be thrown away, and function is going to be called just with a and b. So this is going to work. The problem occurs when we try to call this method on the class itself. So here, self does not get passed in because we're looking up foo on the class itself, that doesn't do any kind of binding. You know, the class itself, looking up a method on that will just return literally what you defined. And here we defined foo to not take in self, but then we wrapped it to take in self. So what we're looking up here is actually a function that's supposed to take in self, and then we'll throw it away. So by not passing in self, we get a type error. And the way to fix that is to use the get method, because the get method is how functions get bound into methods, it turns out. So what's really happening here is that the function class, because functions are objects, there's a function class, and the function class implements dunder get, such that when you look up the function on an instance, it actually returns a bound method, which passes in C as self. But if you look up the function on the class, it doesn't. It just returns the function. So it's the mechanism is in the get method. And so the approach to making a static method decorator is to override the get method. We basically want to not bind self. So here we're going to just write an object, a class, that defines get and just always returns the function straight up. And so this looks kind of confusingly simple, but you have to keep in mind that we're effectively overriding some function class's definition of dunder get. So if the function class dunder get does some method binding, we're basically saying don't, just return the function. And the confusing thing here, or at least one thing that might trip you up, is that you can actually use classes as decorators, because the only requirement for a decorator is that it take in what you want to decorate and it output the result of the decoration. And so here we're taking in a function. When we call this class, we're taking in a function, just like over here we're taking in a function. And then what's the result of calling the class? Well, it's the object that we constructed. And this object has a get method that returns the function. So we can use this class to decorate functions, and it'll work like how we expect. So if we just use the @ syntax on this class, then defining this function is going to immediately construct an instance of good static where bar is func, and looking that function up on a class will just always return the function without doing any binding. And so bar will work how we expect. Questions about this? There's a couple confusing things going on here, because for one, we have get, but then we also are using this class as a decorator, which is kind of weird. And then we're overriding this invisible get method that we actually don't see. So questions about this?
Yeah, why can we use the class as a decorator?
So this is the decorator over here. You guys see my mouse, right? Just checking. Okay, cool. Over here, this decorator is kind of what we're used to. It's a function that takes in a function, defines a new function, and returns the function itself that we just defined. Basically creating and returning a wrapper. But if you look at how this how this ends up getting called, it's not so different from a class. So like a function that takes in a function and returns a function, functions are objects. And so really, this is just a function that takes in an object and returns an object. It just so happens that the object that we're taking in is what we want to decorate, and the object that we're returning is what we intend to replace that thing with. So that's the only requirement for being a decorator. And just like how functions are callable, classes are callable, and calling a class ends up calling the init function. Like effectively, when you call a class, you're constructing an instance, and so init gets called. And what gets returned? Well, when you call a class, the instance that you constructed gets returned. And so you can think of a class as basically a function. The function is object constructor, func. You know, it's a class is basically a function that creates objects. And so we can we can use this class to decorate anything that we want to replace. And what we replace it with is an instance of this class. Does that clarify?
Yeah.
Okay.
Thanks.
It's definitely weird, but it's handy when you want to make it so that the attributes of the thing that you're returning are different. So like here, this function returns just a function, just func. And we defined func with the regular func syntax. So this func is just any other func. It's an instance of the function class, which is exactly what we're trying to change. We're trying to change how these functions get looked up. We want to override the get method. And so we could maybe like change the class of func here, but that would be pretty tricky. Turns out to be easier to just define a whole new class and then use the class as a decorator. So definitely weird. Other questions about this?
So I get how like you can use the class and then it returns an instance of the class. When you call c.bar 1, 2 or class of static.bar, what exactly is getting called then? Because then are you trying to call an instance of the class?
Yeah, great question. This looks weird to me too, because we're using this class to decorate functions, and functions are callable. So it seems like we should have to implement the dunder call method here. Like if we're taking in this func and instances of good static are supposed to wrap that func, then these instances should probably be callable. We should probably implement dunder call and do some star args and stuff. But the magic happens here when you use the dot. Yeah, when you look up c.bar, that's going to look up bar in C's dict. It's not there. So it's going to fall back to class with static dict. And it is there. But because we defined the get method, before returning what was there, it's going to call this get method. And the get method returns the func, not self. So calling c.bar ultimately returns the func, not the good static object. So even though we've turned bar into a good static object, and good static objects are not callable, after looking them up, they are. Because looking them up actually changes what's returned. Does that make sense?
Yeah, that makes sense.
Yeah, it's definitely weird, but that's just part of the magic of get. You get to change what the object is upon being accessed as an attribute. Yeah. Other questions here? All right. So let's look at set here, because set is just as cool as get, in my opinion. Like you might expect, set takes in an object and a value. And hold up, now Zoom is covering up what I want to see here. Okay. And what we're doing is we're setting an instance of this setter class on the object to some value. So this is the set version of the get method that we were looking at. And similar to the get method, this is not changing how we set attributes on instances of setter. It's changing how we set attributes, set setter objects on other classes. So let's see another class here just to test it out. We're going to have just the same setup as before, like with bind me, except now it's setter. And we have an init method. It's going to set x. So we kind of expect this here to call our set function, because here we are setting setting a value that is a setter to something. So here we expect does anybody know what for this line here, what is self, what is object, and what is value? Anybody know? Just go ahead and unmute yourself and Shout it out if you know. It's tricky because set defines how instances of set are set in other classes. So it's hard to keep track of what is what here. But self is still self. Self is the instance of setter. It's X. Self is X. And the object is what we're setting on. So we're setting on this instance of test setter. So this self on the left here, this left self is the right object. And the right self is the left X. And then the value is this specific X that we're setting. Does that make sense? So it's weird because there's two selves, but here the self is X and on the left self is the test setter. All right, so let's see it in action here. If we create an instance of T and we pass in 3 here, this calls init, and so we should expect that this will also call set. So we should get our print statement, and we do. By passing in 3 here, we've tried to set X to 3, and that's what we get, setting setter object to 3. Now if we look up t.x, does anybody know what we're going to get? Any guesses? Well, this is just regular attribute access here. We're looking up X on an instance T. So we check, is it in T's dict? Well, yeah, right? It should be, because we set self.x. Self is T. Self is T here. And we set X, and setting it should set it in the most specific dict possible, self's dict, T's dict. So we should expect that we find X in T's dict, and it should be 3. So let's see what we get. That's not really what we want, because we tried to set X to 3 here, and it looks like it just didn't do it. Anybody know why?
Because we overrode under set.
Yeah, we wrote this set method, but then we just print and we're not actually doing anything. So if we override set, we should actually set something. Similar to like with get, how we should actually make the get method return something. The set method should actually set something. So we need to add a little bit here. The problem is, how are we going to do this? So we're trying to set object. We're trying to set the instance of setter, self, on this object to this value. And the way we would want to do it is to populate object's dict, because that's what we were just saying we kind of expect to happen here. We kind of expected when we did self.x equals x, we kind of expected x, to be 3 on self's under dict. So we have a reference to that. Object is self, and so we can look at object.dunderDict, but we need some way to be able to key into that dict. Like, what's the string that we actually are trying to set in object.dict here? We need to know the string x. We need to know that this self here, this instance of setter, is called x in order to know what to set in the dictionary. It turns out Python gives us support for that through a method called dunderSetName. DunderSetName is a way for us to know what we're called in the class that contains us. So now we can use that name to actually set the value in the objects dictionary. And if we do it this way, then we actually get 3. Questions about that? I know that was kind of like a whole like arc of mental connections to make there. We need to set something, and we're trying to set objects under dict, but we need a string to set it with, which means we need this string. We need the name that we're called in the containing class, and we can get that with this special method here. Questions about that?
So what values of x are taken on as you go through that class like test setter, because like the first line above init is like x like set to like a setter instance, but then if you call init, then you pass in a new x, like how is, or like what value does x have at various points?
Yeah, it's weird because there's kind of there's the descriptor, there's this setter instance, and that's being called x at some points, but then also like the specific value that we want to set is also being called x. So there's different x's at different times. Yeah, that's a great question. This x here, the setter object, the instance of setter, is defined only in the class level. So this is a class level attribute. So if we're looking up x on the class itself, then we're looking up this. What we want is for this init method to change what x is for the instance itself. So this x is in the instance dunderdict. If we were to print out, and I can't remember what I have animated next here, but if we were to print out t.dunderdict, we would hope to see 3 because we're setting this, and this defines a special set method where we're putting that value in the dictionary. So after this is called, t.x and self.x should be 3. But the class level attribute is still the descriptor, it's still the instance of setter. So it's kind of both. It just depends on what level you're looking at. Does that answer your question?
Yeah.
Okay. All right, let's see what I have animated next here, because it might be helpful. I don't know. I forget. Oh, and then if we set it to something else, we get that method called again, and it does actually set it. And if we look at the class level, yeah, like I just said, this looking up x on the class level itself should still be the instance of setter. And I think it is. Yeah, it is. So questions about dunder set? All right, this is kind of a toy example. So we've got a real example coming up here. Here we're hooking into how attributes get assigned to objects. We could raise errors in here, couldn't we? We could restrict the values that certain attributes can take on by raising errors in the set function. So what if we made like a type checked attribute? So we've got this class type checked, and as an init, we're going to take in some type that we want to check against, and we're going to remember that type. And then in the set function, before setting anything, we're going to check to make sure that the value is of the instance type. And if not, we'll raise a type error. Otherwise, we'll do what we did before. We set the object dictionary. And then, like before, we need a set name so we can know what we are. Let's look at how this could be used. We've got a class, Descriptperson. Descript is short for descriptor because all of these classes that we're writing with set and get, they're called descriptors. So this is a Descriptperson. We're going to write this class using our type checked attributes. So we've got name is a type checked string. Age is a type checked int. And so now if we construct an instance of Descriptperson and set the name to max, that should work. p.age to 22, that should work. p.age to the string 22, well, what's getting called here? We don't have any print statements, so it's kind of hard to see, but we're setting this age on this instance of p. That gets transformed into this Descriptperson dot dunderdict age dot dunder set, where the self is the age and the object is the Descriptperson and the value is this string. And this string is not an instance of int. It's not. So we raise a type error. So we should expect a type error, and that's what we get. So there's a whole chain of calls going on here. It's kind of hard to follow, but basically we've defined how these attributes get set. This is kind of similar to defining setAttr in the Descript person function, but it's a lot cleaner because if we were to write like a type checked class with only set adder in the descriptor person class itself, we would have to have a big long if statement like if the adder that you're trying to set is name, then check if the value is string, raise a type error, next if statement. But because of this nice descriptor protocol, we're able to separate out the type checking logic into each individual attribute. So it's just one set method for defining multiple instances. It's very clean. And it also has the added benefit that this looks very similar to Java. So it's not only is it a clean, very concise way of representing how these attributes should get looked up, but it also ends up looking really nice too. Questions about this? So descriptors go very well with metaclasses. And that's because here we're adding these attributes to the class itself. You know, this isn't how we're used to doing it. We're used to doing it in the init method where we take in a name and we set self.name, we take in an age and set self.age. But here we're defining them on the class level so that we can override how they'll get looked up and do cool stuff like type checking. But because we're setting them on the class level, we have an opportunity to do some really cool class level computation to enhance this class, descriptor person that we're writing. And what do you think when you think class level computation? I think metaclasses. If I want to change how some class definition is actually getting computed, I think metaclasses, because I need to go up a level. I need to change how instance of class itself is implemented. So let's take a look here. We're going to make descript person implement a specific custom metaclass. So this is going to throw us right back to metaclasses. Here it is, metaclass, auto init. And my goal here, our goal here is to write a metaclass that will automatically generate init methods for us. So if we look back at this class here, we defined name and age, but then when we constructed our instance, we didn't pass in name or age. That's because we didn't have an init method. We didn't define it. But it would be kind of annoying to define it, right? Does anybody else get sick of writing the exact same init method over and over and over again? Like it's always just taken x, y, z, set self.x, set self. It's very repetitive. And metaprogramming is great at eliminating repetitive code. So we already have exactly what parameters we want here. If we wrote an init method, it would probably just take in name and age. So why don't we just generate that code automatically? That's what this metaclass is going to do. Our metaclass is a subclass of type because type is the class for classes. And new is the method that you call before init. It's responsible for constructing the instance of auto init. The instance of auto init here is descript person. And we're going to get all the fields. What is adders here? What are these three things here? This is a callback to metaclasses. Does anybody want to remind us? It's okay if nobody remembers, because this was a long time ago now, especially with spring break and then spring break plus plus. But
it was a dict of all the fields belonging to the class definition.
Yeah, this class definition here will end up getting passed into the new method as a dictionary. So for example, this class definition, the dictionary that would be passed in is string name mapping to type checked str. String age mapped to type checked int. So this would be passed in as adders. So we're looping through adders and getting everything if it's an instance of type checked. So this is one example of how metaclasses and descriptors go well together. Because we defined all of our attributes as instances of a specific class, it's very easy to extract those instances when we're doing kind of meta processing. So we're going to get all of the things out of that dictionary that are of instance type checked. And we're going to join all of those fields. So the fields are here, it's the key in the dictionary. So it should be, the fields are string name and string age. We're going to join them. We're going to comma separate them. And then we're going to construct this kind of convoluted string. It's going to be new line, 4 spaces, self dot, and then f, where f is the field, equals f, where f is the field. Does this look familiar, people? This is kind of the archetypal init method body, isn't it? It's indentation, self dot, thing equals thing. That is like the classic init definition. So let's put it all down here. Code is going to be def init self args colon sets. What are we doing here? We're constructing a string that looks just like the init method that we would have wanted to write. That's kind of cool. Does anybody want to guess what the next line is going to be?
Is it eval?
Oh, yeah, so close. Not eval, exec. Eval evaluates the string and returns what it evaluated to. So eval would return us this init method. We don't want to return the init method. We want to, this string is a definition, so we want to execute the definition. We want to define it, basically, and by executing it, we're defining it. The cool part here is, if you might remember from reflection, you can pass in the dictionaries that you want to do this exec in. And here we're doing the exec where the locals, we're passing in adders as the locals. What is that going to do? That's going to make it so that this definition actually operates, defines in the class body. So we're execing this code as if it had been written right here as part of this dictionary, as part of this class body. And after doing that, then we return the super new. We're just going to do what otherwise would have happened. But now, adders is going to have this extra pair, key value pair, where mapping init to this, this class body that we just wrote out as a string. And if we run it, we can now call a descript person while passing in parameters. And it's calling this imaginary init method that we didn't actually write. And the init method, because it's using just straight up, dot set, is also going to take advantage of the type checking. And so not only do we get this init method, but we also get the type checking that came with the type checked descriptors. Questions about this?
Is there a way to do this without writing out the code as a string and using exec?
Yes. So we also could have defined an inner function with a closure. So like we could have defined a function just called init, like just as code, just a nested def basically, and then assigned that def into the attributes. That also would have worked. The reason I didn't do that is because I wanted to use reflection, because reflection is cool. And it's, I feel like we never really got to see a very practical example of exec. Exec is you almost never see it in production code. It's very insecure. I mean, executing arbitrary Python strings, like, I don't know about that. But one of the ways you actually do see it legitimately used, and this is true for the built-in Python libraries actually, is to do exactly this, executing code in a class body. One reason this is preferable to using a closure here is it's much faster. Defining a closure and then setting that closure object as an attribute value is actually quite a bit slower. And that's just because of how CPython optimizes method calls when it can. It turns out execing the code here, it's able to compile some method calls early that it wouldn't otherwise have been able to do. So yeah, good question. There's other ways to do this, but exec is actually the fastest. Other questions here? I hope this is thoroughly mind-blowing. I know it is for me. The fact that you're able to construct Python code as a string and then execute it in a class body that you are instantiating because you're a meta class. Like, there's just so much going on there. But it's really handy, right? Because who likes writing those init methods? I don't. Yeah. Okay, if there's no questions, yeah, summary, who cares? I've got some really cool code to show here. And this is one of the reasons that I wanted to spend extra time on descriptors, is because after writing this slide set last week, I actually ended up using descriptors in some code that I wrote literally yesterday. And I think it's just really cool. So I want to show it to you. So does everybody still see my screen? Can I get a thumbs up if you're still seeing the screen? All right, cool. All right. So I'm currently in the middle of writing. This is not complete code. I'm currently in the middle of writing a COVID-19 spread simulator, kind of like the ones that you might see on the Washington Post. I don't know if you guys have seen that, but they model out. I guess I could pull it up because I'm sharing my screen, but I don't. They model. You know what? I'm gonna do it. No, I'm not. They model the spread of the disease by modeling people as little dots that like just float around in space and bump into each other, and then it starts with one sick person, and that sick person bumps into another person, and then they're both sick, and so they model the disease spread in that way. I thought that's cool, and people have been like doing more and more advanced simulations on that, so I kind of want to get in on the action. Not to mention, it might be useful for a certain class project that's coming up. So I just started writing, and I've got this simulation class here. First thing to note is that these are all class level attributes, just like we were seeing here. But I'm setting them equal to just ints. So these aren't descriptors, like int is not a descriptor. But the cool thing is that this data class decorator is actually going to turn them into descriptors. So data class descriptor is something that's built in. It's new in Python 3.7, I think, and I'm a big fan. It makes it so that you can define these class level attributes without using custom descriptors, but it'll give you the descriptor for free. And similar to like we just saw, it'll also give you an init method for free. So like all of these have default values, but because we use data class and these type annotations and all this stuff, when I construct an instance of simulation, I can pass in nothing, or I can pass in like num. See, it even autocorrects. Num trials equals 1,000, and that's because the data classes library gave me an init method with a bunch of keyword arguments for free. So that's pretty cool. The way that's implemented underneath is with descriptors, metaclasses, and exec. So the exact same thing we were just writing. It's just that built in, it's a class decorator instead of a metaclass. So that's cool thing number one. Cool thing number two is that this simulation class, I want to have components of the simulation that use these values to define their behavior. So for example, a person, if I have a person class and the person has like decide to go to the grocery store method, I want the output of that method to be dependent on these global simulation variables. And how does one usually define subcomponents that have access to the supercomponents? Nesting. And so I have this inner class. This class is defined inside of this class. This isn't something you see very often. And it is also a data class. It has its own stuff, but also it has access to the simulation parameters. So what's a good example here? Yeah, so constructing a person object, we get the grocery frequency from this global normal distribution that was defined on the simulation level. And you can see here, I'm doing class.simulation.grocery frequency. Where did this .simulation come from? Because it's not defined up here. And it's not set anywhere else. Well, it turns out the way I did that is by making person inherit from simulation component. And simulation component has a custom metaclass, and this custom metaclass defines get. So what's actually happening here is that these inner classes, the class itself defines the get method. You don't see it here, but it's because it's inherited from this instance of a metaclass. So the class itself has a get method, which means looking up instances of capital P person, looking up capital P person itself on instances of simulation will call this get method. And you can see that this get method actually creates a new class that inherits from the original class, but with this simulation thing set. And then that's what gets returned. So how does this work? Well, let's look at this init function here. This is the simulation init function, setting up, for example, the list of people or the list of cities. And you can see a loop through the number of cities, append self.capital C city. What is that? We're looking up the capital C city. This is, doing an attribute access on an instance of self with city, capital C city. But capital C city, we defined it down here. It's a subclass of location, which is a subclass of simulation component. So this also has the dunder get method implemented. So looking up city on self is going to call that get method and actually return a subclass of city with an extra parameter here, simulation. And that's going to be set to self. So the cool thing here is that by accessing capital C city on the instance of the simulation, then objects of this city class are going to have that simulation variable set just by doing this. So, if you've looked at code like this in the past, a lot of it requires that, maybe this person class also has a simulation thing. Every single one of these inner classes would also have to define, and we have to remember the simulation we're in. And then you would have to define an init method where you explicitly pass in the simulation. So like here, when we're constructing the instance of city, we'd have to say from params self. We'd have to pass in the instance of the simulation so that it knows about it. But the cool thing is because of the descriptor protocol and our custom get method, we're able to give instances of city the reference to simulation just by doing this attribute lookup. Effectively, what we're doing is we're making it so that these inner classes are bound, kind of like how methods are. Methods get an instance to self, because of the way they're looked up on the class. Classes by themselves don't have any kind of bind characteristics. But because we implemented the get method, we've added some bind characteristics so that instances of this person class have a simulation variable that they can access. Questions about this? I know this isn't a slide, so it's not laid out very nice, but...
What's the point of generating and operating on subclasses when you could just make instantiations from the main, like for instance with the cities, like you said you were generating subclasses of city with that from params method call?
That's because the simulation is going to be the same for all of those cities. Every city we make is going to have is in the same simulation. So really, the simulation should be a class level attribute, not an instance level attribute.
Hmm.
So we want to make a new class with that class level attribute.
Gotcha.
Yeah, good question. I mean, we could have done it with instances, but that would have been a little bit less efficient.
Mm.
Yeah. Other questions here? I know this was really brief and quick, but I just, I'm not going to put this code on Metaprogramming repo because I'm going to put this in its own repo probably. But I'll send you guys the link as soon as I put it up. Also, I'm aware that I never posted the slides from last week. I will do that. Yeah. I'm out of time, so I'm gonna say that class is officially over. But if you have your reflection homework up and want any help with that, I'm gonna stay in this meeting, and feel free to just hit me with questions about reflection or questions about this. But yeah, if I know you guys have other classes to go to, and you probably want to, not that you have to like physically go, but maybe you have to like make coffee or something. I totally understand. So yeah, thanks for humoring checking out my simulation.
Thank you.